Hello guys, and welcome to another Emacs video. So in this video, we are going to talk about the configure options for an Emacs build from source. We talked about the auto tools, we talked about the dependencies, and of course configure is how the manufacturing floor of Emacs is going to select its build tools. It's also going to control which parts it wants to use if it wants to control those parts. And there's a lot of functionality that we can get from the options that we pass to configure, which is the script that checks the manufacturing floor for the parts that are available. You can think of the robot Emacs that's found itself on Mars. It's searching around for what resources are available. It's going to find those resources, and then it's going to build itself into an Emacs robot. So we're really providing the dependencies to get the build that we want. Then the configure options are going to say, okay, hey, I want you to use some of these dependencies, or I want you to build this robot so that it can go in one location or build it for another location. We're going to be able to specify configure options, and we want to look at those configure options in this video. Now, if you want to learn a little bit more about the auto tools, which the programmers actually use to build the configure options, to build the auto scripts, and the auto tooling that enables Emacs for us to build Emacs from source, we need these auto tools. You don't get to look at this when you're talking about programs like Microsoft Word.exe or other Windows programs that have the exe or proprietary software. But when you're using Emacs, when you're using open source software from GNU, you actually get to look inside of the software and see how it works. So it's educational for us. And now here's a link that you can look at, this URL. You can go ahead, you can go to that URL, and you let's just decrease this a little bit. And so we're not wrapping the text. You can see the full URL. You can copy that. You can go learn a little bit more about automake, autoconfig, all the GNU auto tools. So here we have the configure. Again, it's a shell script, auto-generated by autoconf. It prepares your build environment, runs around the manufacturing floor, and checks for all of the dependencies that exists, and then it creates a plan so that the make program and make files can actually build our software, build our little Emacs robot. So given the text, configure performs tasks like checking for required libraries, header files, detecting system features and quirks, determining installation paths using the prefix argument, for example, and generating project-specific make files and configuration headers. So functions to get features and configure options Emacs was built with. These functions you can install from a package manager. You can install Emacs from a package manager and see which features and command line arguments it was built with. Then you can build it on your own from source using the exact same arguments from the configure arguments. As long as you have the same dependencies installed, it should be good. So here we're going to look at a couple of functions. This is copy your Emacs features to your clipboard. So we can go ahead here like this. We could instantiate that, and then we could go with my copy, and we could have a look at build the features from the clipboard. They're on the clipboard. So this will tell us everything that this Emacs installation that we're looking at right now, what it was built with. It's got G settings, it's got HarfBuzz, it's got JPEG, Cairo, Dbus, all of these programs. And this next one, you could look at the actual configure options. So if you wanted to know what the configure options were, you would just go to the end of this and get Control XE. And actually, let's turn on let me just turn on the key toggle so you can see up in the top corner here the keys that I'm pressing, and then you can see the function that is running again as well. So there we're doing eval last expression. This is really evaluating this function, and then you could run that function to find out what the configure options were. So you install Emacs from a package manager, you want to know what it was built with, you can use these two functions, find that out, and then you can build it yourself. You get a better piece of software. So this is a Flatpak configuration. Comes from the README from Flatpak. You can see the configure options that were used to build the Flatpak build. They've got some extra options here. I don't think you need these. They've got with tree sitter, with modules, with JSON, with PGTK. Maybe that's for Wayland. Maybe you want that. With GNU utils, a lot of these are kind of included. With zlib, you need. So yeah, I don't know if they need all those. Maybe they had to decide. Maybe they had lots of extra other options. But we're going to look at a pretty slimmed down build here. So this is an X11 GTK compositor build. If your system uses X11, you can just go ahead and you can build like this. That's good enough for you. We've got the C flags here. O2 is relatively safe, so we're more or less good to go. We're going to discuss these in a moment. Now for the Wayland build, Wayland compositor build, I say it's better. It's the one that I'm using. This is everything you need. You can copy this, go ahead, you can build on Wayland. So let's go ahead and discuss these and talk about just the options that are used for the build that we're going to do in the next video. This is the full build. We'll just talk about these configure options. And here's a URL you can go to where you can look at all of the configure options for Emacs and all of the configure options for configure. Read a little bit about them if you wanted to know how many options there are, what you might want to use those options for. You can go ahead and read that document. So the installation layout, where, make, install, puts the files. This is a well-used argument, sets the top level install route for all of the tools. So this is really your cleanest way to keep your custom Emacs separate from the one that your distro manages. So this defaults to prefix user local. So if you build Emacs from source, it's going to go into the user local. It would go there as well if you were installing it from a package manager. And that's going to be on your path. So that means that you always be able to just type Emacs into the shell and you'll get it. You're also going to get some desktop shortcuts that'll be available in your menu down in the bottom of the screen here. Or if you're using WSL, WSLG, they would be available in your Windows menu if you went and you built Emacs from WSL. Now, if you include a prefix argument in your .configuration argument that is not user local, then if it's en route, it may still be on your path. It depends which is closest, but it's not going to write your desktop files. So when you build Emacs from source, it is, if you want to change this prefix, you can build multiple different versions of Emacs with multiple different types of configure arguments. You can experiment. There's only one that is your default configuration, and that's if you do not use a prefix argument. Very common for source builds, parallel installs in 2025. The graphical backends Windows system, X11 toolkits, Wayland, PGTK, these options decide whether Emacs actually builds with a GUI at all, and if so, which Windows system stack it targets. So on 2025, you would typically choose with PGTK or not. It defaults to the Wayland first. So this is the actual package down here that we're going to use with PGTK. Once again, actually, the actual package is the libgtk-3-dev. That pulls in a lot of libraries, gives you a lot of functionality, and that's really for the GTK build. That is what gives you the pure GTK build. So it defaults actually to X11. So if you use as your main tooling system, you use the GTK libdev GTK3 or libgtk3-dev-3-dev, then you're going to be getting a Windows specific X11 build unless you use this with PGTK argument. With PGTK in the configuration means Wayland first, and then a lot of the X specific tools are no longer flagged as operating when you get your final Emacs build. So that's really how you decide between Wayland or X11 is with this argument. If it's present, you're using Wayland. If it's not present, this configure option, you're not using Wayland, you're using X11. So native compilation via libgccjit, libgccjit. Native compilation is much faster, closer to the machine. All your Lisp files that come with Emacs, they're byte compiled, and you want to make them native compiled from byte compiled. So you want to do this. You want to add this onto your system, libgccjit, and this would actually be in alignment with your GCC toolchain. That's kind of could be a problem if this was a 9 and your GCC toolchain was a 14, then it wouldn't work. So you would want this to be, if this was a 14 here, and this was a 14 as well, then, it would work. So I chose 9, some arbitrary number. You could say 7, or, you could say 4 or 5 or 6, whatever numbers you want. If you like to play with numbers, they have to be in alignment, and that's what's important. So this gives you the native compilation. The actual argument for your configure options is, with native compilation, speeds things up a lot. So in terms of developer diagnostic, build behavior, warnings, checks, debugs, here we're talking about verbosity. This is disable the silent rules. So the build for the configure options with Emacs, it doesn't have a lot of text. If you add this, you get a lot more text. You want more text, you can see what's happening, you can learn about it, or if you don't, you can just leave that one out. Now, in terms of garbage collection, this is a nifty little option. Disable GC mark trace. What this is going to do is give you 5% better performance in your garbage collection, but the trade-off is that you'll have a little less debugging power. So you're going to have some runtime efficiency. You're going to be trading that off with your debugging ability. So if you were really doing a lot of debugging, you're building Emacs packages, you're building Emacs, then you're going to be wanting to play around with this disable GC mark trace. We're going to include it in our build, which is up and coming in the next video, because we want to get that better performance. We'll include it in one of our builds. So toolchain dependency discovery override. So these are like environment variables, maybe you can think of them as environment variables. We're really talking here about C flags. So there's a lot of text here, and let's not worry too much about all of this text. We've got the default, non-default toolchains, Clang instead of GCC. We have some C flags where we can more specifically narrow down on the C compiler flag. So this is what we want. Let's not worry about that too much. Let's focus on the C flags here. The C flags for the compiler options, they configure checks of the final Emacs build. So we've got debug info, hardening, CPU tuning. For normal native builds, you want to choose the -2 option rather than the -3 option. I'm going with the -2 option. I've been using -3 for quite some time. It seems to be working more or less on my system, but we will go with the stable option when we do our build here. So in terms of optimizing for size, this is OS. It makes it really small, but it can hurt your performance. Disables some important optimizations. So O2 is considered safe and well tested. O3 adds marginal speed at the potential stability cost. So we've got aggressive optimizations like O3. So in terms of C flags, we're going to go with -O2. So March native tells GCC to generate specifically for the CPU that is compiling Emacs. So that's much more streamlined. It enables sets and features that the CPU supports. So it's targeting your CPU. The resulting binary will be faster on your machine, but it will likely not run on older or different CPUs that lack those instructions. So when you use March native GCC, you're getting system-tuned Emacs. So that's one of the reasons why we built from source. This also implies, that the mtune native as well. So if you include March native, you do not need mtune native. Now, mtune native asks GCC to optimize the scheduling and other CPU-specific heuristics for the local machine while still generating code that remains compatible with the base architecture. So what's the difference between mtune native and March native? Mtune native runs on a few more machines. It's a little bit more acceptable across different machines, whereas March native is more specific to your machine. And so you get a little bit better performance for your specific CPU. So if you're building for a group of people into a Docker container, maybe if it's in a Docker container, you would use March native. But if a lot of people are going to be installing your Emacs, then you would maybe use mtune instead. So fno math errno. By default, GCC assumes math functions like a square and log, for example. Pardon me again. It may set errno on error, which limits some optimizations. So we're talking here about more aggressive inlining and vectorization. This is safe if your code does not rely checking Emacs after math calls. So it's recommended for performance. It is reasonable to include math and errno in the C flags. This fsanitize undefined, we probably don't want to include this one. It inserts runtime checks for many formal undefined behavior, out of range shifts, invalid casts. This is extremely useful for debugging and finding subtle bugs, but it adds noticeable runtime overhead and it can even crash your system. So we definitely skip that one. -G tells GCC to include debug information in the compile binary, so you get a lot more detail in terms of your debugging. This file size grows somewhat and builds can be slightly slower, but the runtime performance is pretty negligible. So it takes a little longer to build, but it gives you a little added debugging when you actually do use the debugging. So we include that. Vomit frame pointer. This is like a dedicated frame pointer register to keep track of stack framing, which is tells GC to skip generating explicit frame pointers when it can still unwind the stack using debugging information. What do you need to know about this? Include it. It may make low-level debugging with primitive tools less convenient, but it does optimize for production build. It gives maximum ease of debugging on all systems. You would omit it, but if you want higher performance, you would include it. Okay, so in this lesson, you learned about the configure options used to build Emacs with GNU Auto Tools. You also got an example of configuration options you can use to build Emacs from source in Ubuntu 25.04 and 2025, and 2 ELIST functions to examine the configure options and features that were used to build any Emacs installation, including those installed from package managers. In the next lesson, we're going to go ahead and build an Emacs program from source files in a Docker container. So you definitely want to watch this next video. It's going to give you everything you need to know, all the configure options, all the dependency options, and then we're going to go ahead and build it on Ubuntu 25.04 in a Docker container so you can see how Emacs searches around looking for these different dependencies, these resources that are available, and then it builds based on what it finds on the computer system. So that's it for this video. Thanks so much for watching, and we're looking forward to seeing you in the next video.